Problem looking at quantum numbers. Identify the shell and subshell of an orbital with the quantum numbers, and they give you 4 different examples. Okay, if I am looking at the shell, what is the quantum number I should look at? Is it n, l, m sub l, or m sub s? The shell is our n quantum number. What is the subshell? What is the quantum number associated with that? This is L. Let's do the first one so you can kind of see what I am looking for. If our n equals 3, we are in the third shell. Okay, and that's what we need to find. We need to tell the reader what the shell is. So our shell is the third shell. What is the subshell? Well, remember, L equals 1, that's our subshell. What is the notation to denote that if L is equal to 1? We call that the P subshell. So they are just looking for 3P. M sub L, that will give you how many orientations you can have. And M sub S, this just tells you if it's spinning clockwise or counterclockwise. I want you to go through and I want you to do the rest of them, B through D. Here's the second problem involving quantum numbers. Give all of the possible combinations of quantum numbers for the following orbitals. Let's do the first one together. We have 4 quantum numbers, right? We have n, l, m sub l, and m sub s. What would our n have to be? Our n is going to be 4 because that number out in front, that represents our n. That represents the shell that we're in, or the energy level, same thing. What would our L have to be? Because we have a P subshell, the P represents our L, but we have to get a number. That number you have to memorize, and that's going to be 1. So L will have to be 1 in this case. Now, if we remember, L or M sub L can have any values, what values? Anything between negative L to positive L. All right, so if L equals 1, M sub L, what value could it have? Well, it could have multiple values, but in this case, let's say it's negative 1. And then M sub S, this tells you the spin, and I'm going to cheat, in a sense, and I'm going to just say plus or minus 1/2, because it can have a positive spin or it can have a negative spin, clockwise or counterclockwise. Okay, now that is one possible combination that 4P could have. Another combination, let's do that one. What would our n have to be? 4, since we're still 4P. L would still have to be 1. But this time our M sub L could change. What could it change, or what is a new value it could have? It could be 0. And M of S could be plus or minus 1/2. Could we have a third one? Sure. Our N would still have to be 4. Our L would still have to be 1 because it's a 4P. But what would our M of L have to be? It could be a plus 1. And our M of S would still be plus or minus 1/2. Okay, could we have a fourth set of quantum numbers? No. The reason why is because the m sub L limits us. We can only have 3 values of those. So that would be our answer for 4p. I want you to do the next two, 3s as well as 4d. Here's a third problem involving quantum numbers. If the electron's quantum number address is described as n, l, m sub L, and m sub s, which of the following can occur? I want you to do this problem. I'm going to give you a hint, and I'm going to say that only 2 can occur.